Assalamu alaikum, dear students. Welcome to the 10th program in operating system series, and today we'll continue our discussion on the file systems. And today we'll discuss on the implementation aspects of file systems. Let's have a quick recap of our last program. And you'll remember in our last program we discussed file naming conventions, file structures, file types, file access, file attributes, file operations, and we also discussed directories, and we discussed hierarchical directory system, how the paths are set, and we discussed directory operations commands. You will recall that in our last program we did discuss the file system and files and directories from the user perspective. Today we'll be discussing directories and files from the implementer perspective, and today we plan to cover implementing files, implementing directories, disk space management, file system reliability, file system consistency issues, file system performance, and file system security issues. Now let's get going to the implementing files. While we think of implementing file, we essentially cover how the files which the users create are stored on the media, and there are primarily 4 ways in which we implement files. Number 1 is contiguous allocation. Number 2 is allocation using linked lists. The third method of implementing file is allocation with the linked lists and indexes, and allocation with index nodes. All these methods and schemas are used for implementing files, and each of them have its advantages and disadvantages. In contiguous allocation, the operating system allocates n contiguous blocks to a file, and let's say if the file was of 100K in size and our block size is 1K, we'll need 100 contiguous blocks to save that file of 100K in size. And the advantages of the contiguous allocation are it's very simple to implement, because keeping track of the blocks allocated to a file is reduced to storing the first block. And in the contiguous allocation, the read-write head has to move very little, and as such that gives us an excellent performance in the implementation, because the read-write head has to move very little, and we have a contiguous block of let's say whatever our file size is, and this gives simple implementation. Read-write head has to move a little, as such it gives a very good performance. The contiguous allocation is simple to implement, and it gives good performance. It has certain drawbacks. Let's look at what are the drawbacks of contiguous allocation. The drawbacks are that operating system does not know in advance how much space to allocate for the file, because the operating system does not know the size of the file in advance. That is the biggest disadvantage that we have in the contiguous allocation. The second problem which we have with the contiguous allocation is that it leads to the fragmentation. As the size of the file changes, it grows or it reduces, it leads to the fragmentation in the file system. Although we can run the defragmentation process, and if we run the defragmentation process, it is a costly operation. Dear students, the second implementation scheme of the file system is use of the linked lists. In the linked lists, the operating system keep track of the first block allocated to the file, and then in the first block could contain the data as well as it will have a pointer, and then to the next block which the file occupies, and so on, and this scheme continues. And in this scheme, the blocks of the file are represented by using linked lists, as I mentioned, and what is needed is the address of the first block that the file occupies, and each block contains data and a pointer to the next block. Gentlemen, let's look at how the file systems are implemented using the linked list with the help of a diagram. In this diagram, we see file A, file B. File A consists of these 5 blocks: file block 0, file block 1, file block 2, file block 3, and file block 4. But the physical addresses of this file A is different. The file block 0 is physically on physical block 6, file block 1 is on physical block 9, file block 2 is on physical block 4, file block 3 is on physical block 12, and file block 4 is on physical block 1. And similarly, we see that file B occupies 4 blocks, and in these 4 blocks, file block 0 is on physical block 11, file block 1 is on physical block 2, file block 2 is on physical block 4, and file block 3 is on physical block 8. And we see from one block to the other block there is a pointer, from block 0 to block 1, from block 1 to block 2, from block 2 to block 3, and similarly from file block 3 to file block 4. And we also see in this file B, we have a pointer from block 0 to block 1, block 1 to block 2, and block 2 to block 3. We saw that the implementation of files using linked lists is different than the contiguous. In the contiguous, blocks are consecutively allocated, but in the linked list, we have, as we saw in file A, we have different physical blocks occupy the data and the pointers, and similarly we saw in file B, the different physical block numbers actually occupy the data, and that leads us to some advantages of using the linked lists. What are these advantages? Let's look at that. The first and foremost advantage of the linked list is that every block can be used, unlike the contiguous allocation, and no space is lost due to the external fragmentation. The directory entry only has to store the first block number, and the pointers leads to other disk blocks. The size of the file does not have to be known in advance, because the blocks we can increase from randomly. We can increase the number of blocks for a file randomly. And the last advantage of the linked list is that when more space is required for a file, the first block on the free block list may be allocated. Although the linked list yields some advantage in terms of space usage, but it certainly has some disadvantages. And what are these disadvantages? Number one, random access is very slow, because whenever we want to access a file from somewhere in the middle or somewhere in between a file, we have to go to block 1 in order to track that point in the file. As such, it leads to the random access is very slow. Another disadvantage of the linked list is that space is lost within each block due to the pointer. It means since each block will have to have the pointer, and that pointer occupies some space, and that leads to some space utilization inefficiency. The another disadvantage of using the linked list is the reliability, which can be a problem. If in the linked list, if you have just one corrupt block can disrupt and damage your file system. As such, the reliability is a problem in the linked lists phenomena and linked list utilization methodology. The experts have modified the linked list scheme in order to overcome the disadvantages of the linked lists, and that is using a linked list with the index or with an index table. How it's done, let's see. In the linked list allocation using the index, we primarily all the index of the allocated block and the free block is kept in the memory. As such, the random access is possible, and this overcomes the disadvantage of the linked list, simple linked list. And if we have linked list and an index or an index table in the memory, we can certainly overcome the disadvantages of the simple linked lists. Because it stores the pointer in the index table and it does not waste space in the block. Another disadvantage which we mentioned in the linked list was that pointer occupies some space. In this case, the pointer does not occupy any space because we have an index table. In the linked list allocation using the index, we primarily all the index of the allocated block and the free block is kept in the memory. As such, the random access is possible, and this overcomes the disadvantage of the linked list, simple linked list. And if we have linked list and an index or an index table in the memory, we can certainly overcome the disadvantages of the simple linked lists. Because it stores the pointer in the index table and it does not waste space in the block. Another disadvantage which we mentioned in the linked list was that pointer occupies some space. In this case, the pointer does not occupy any space because we have an index table. Another attribute of the linked list using the index is random access is possible and faster, as index is always kept in the memory and its retrieval is easier. In this table, we see the physical blocks 0, 1, 2, 3, and we see 14 blocks, and we see the pointers, and if the block is empty, then we say this is an unused block. There is no pointer. In the index table, we say this block is not used and this block is empty. Let's say our file A starts from this physical block 6, and in the physical block we have a pointer to 9, physical block 9. We go here 9, and from 9 we have a pointer to physical block 4. We go to 4, and from 4 we have a pointer to physical block 12, and from 12 we go here. It means our file A file A occupies the block 6, block 9, block 4, and block 12, and block 1, where our file A closes. Okay, and similarly we see our file B starts from the block 11, and we have a pointer to block 2. From 2 we have a pointer to 14. From 14 we have a pointer to 8, and from 8 we have no pointer. 0 means that our file ends here. It means our file B occupies the block 11, block 2, block 14, block 8, and at block 8 our file closes. This is the way files are implemented using linked list, but with the help of an index or a table which is kept in the memory, and that yields a benefit of we can randomly access the file, and we can the access is faster. However, it also has certain disadvantages. What are that? Let's look at that. As I mentioned earlier, that file B occupies blocks 11 to 14 and 8, and random access is much faster, as given offset can be located by using only memory access until the correct block has been reached. The main disadvantage is that the entire table must be in the memory all the time. For a large disk, say 500 1K blocks or 500 MB size disk, the table will have to have 500,000 entries. That is the biggest disadvantage that we have having the index table in the memory. And as you know, these days we are having the disks of larger size in gigabytes and even in terabytes. Keeping that large size table in the memory is expensive if we implement the file system using linked list with index table. That leads us to another scheme which we use for file system implementation, and that is use of the index nodes or inodes. In the inodes, all the attributes of the file are stored in an inode or called index node, which is loaded into the memory when the file is opened. The inode also contains a number of direct pointers to the disk blocks. Typically, there are 12 direct pointers to the disk blocks where the data is stored. In addition, there are 3 additional indirect direct pointers, and these pointers point to further data structures which eventually lead to disk block addresses. First of these pointers is named and is a single level of indirection. It provides us a single level of indirection. The second pointer is called the double indirect pointer and provides us a 2-level indirection. And third pointer is called triple indirect pointer. Gentlemen, now let's look at how the inodes are implemented with the help of a diagram. In this diagram, we see we have an inode which contains the attributes of the file, and we have the blocks disk addresses. And normally, as we mentioned, we have 12 direct pointers to the disk blocks. As we see, these pointers direct to the disks. And apart from that, the 3 additional pointers which we mentioned this here, pointer 1, pointer 2, pointer 3, which provide us a single, double or triple indirect blocks, is one pointer goes to here, and from here we have again 12 indirect blocks and the pointers to the direct disk blocks. In this double indirect block, we see here this pointer coming from the inode, double indirect block, and this indirect block is true level. Here we have again pointers to another level as well as data blocks. Some of these blocks will be used for storing the data, and these 2 pointers will lead to another nodes, and in these nodes again we'll have pointers to the disk blocks where the data is stored. In the third or triple indirect block, we see here we have 3 levels. We have one node which contains the pointers to the data blocks as well as to another level of inode we see here, and yet another level of inodes. It means starting from the base inode, we can have data pointers directly to the data, or the pointers to the single, double or triple indirect blocks, and as such we can have the bigger files and large number of blocks to be occupied by the files. And as we see here, these are the addresses of the data blocks. Ultimately, we end up in the inode, we end up with the address of the data blocks where physically the data is stored.